Hey students, a pleasant greetings to you all. Welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education, where we primarily focus on learning this beautiful language of the universe. And in today's video, we're going to be looking at the application of the distributive law in algebra. Now, before we actually get into this video, I primarily focus my contents on the Csec, SLC, SEA Caribbean examination body. That is where we focus primarily on preparing students for exams on a yearly basis or on a tri-monthly basis. Of course, if this is the first time here on the channel, do not forget to hit the subscribe button below, turn on your post notification bell for daily uploads between the hours of 5 p.m. and 9 p.m. every day, where I teach my live classes. Also on weekends, we do provide tutorial contents on various aspects in math that students often tend to find a challenge with. My aim and focus of providing video content for you guys is to improve the way how you look at math. Math can be extremely fun and extremely easy once we have very strong and sound fundamental. Of course, hit the like button if it is that you appreciate the content and it's of any value to you. Leave your thoughts and comments down in the comment section below. Looking forward to hearing from you. So let's jump right into today's lesson. Of course, as I said before, we're going to be looking at the application of the distributive law in algebra. And by definition here, you'll see that the distributive law, in fact, states that if a term, which when I say a term, I refer to a number or a letter or a combination of a letter and a number, is outside of the parenthesis, and it has to be immediately preceding the parenthesis. Then how do we simplify an expression? Then it is that we use whatever is on the outside to then distribute or multiply all of the terms that are inside the parenthesis. All right, now this is a fundamental concept behind the distributive law. So of course, we're going to be doing probably a part 2, give or take, say here, if we can spend at least 45 minutes or less on this video. All right, so let's get right into it then. So what we're going to be looking at are a variety of basic examples. I strongly believe that students struggle in math simply because they have very weak fundamentals. If you can give your fundamentals some strength, some muscle, then you're going to find that no matter how difficult the math gets, you'll be able to peruse through the questions without any hiccups. All right, so I'm going to be walking through a bunch of different examples, but before I actually get into the questions that you just see popped up on screen, let us take a fundamental approach to this. And we're going to be starting off simply by some just random examples that I come up with here. And so on screen, let me grab my pen out here. All right, and what we have then is, in fact, say here, we have a number 2 outside of a parenthesis, and that is being distributed with, say, for example here, x plus 4. Okay, or let's just use 2 letters and x plus y. Okay, now we really can't do anything to this type of expression simply because one of the fundamental rules when it comes to adding and subtracting algebraic terms is that unlike terms cannot be added. Do see the link in the description or right here in the cards where we discuss fundamentally the addition and subtraction of algebraic terms. Check that video out. So here we are not allowed to add terms that are unlike. Hence the PEMDAS rule is not applicable here. So the only thing that we can do in this simplification process here is simply use whatever is on the outside, say here, to multiply whatever is on the inside here. So this now therefore gives us valuable information going forward that bracket implies multiplication. Okay, so it's very important that once you end up with a binomial expression, and a binomial expression is an expression that is combined by two unlike terms. Once you end up with a binomial expression that cannot be added or subtracted with a number outside of the bracket, then we simply use whatever is on the outside to multiply what is on the inside. So therefore, what do we have here? 2 multiplied by x is in fact 2x, and 2 multiplied by y is 2y. It's a very simple problem for advanced intermediate students who have strong fundamentals. This is very simple. But what am I trying to get at here? I'm trying to get average or below average student to start to appreciate algebra and its simplicity. So let's then extend this from a positive number to then a negative number. Let's say we have negative 3, open bracket, 5 minus 2y. Let's do something like that then. Okay, so what we're going to be doing next is using the term outside to multiply the terms inside. Now, what I do find a challenge with when teaching fundamental students is that they oftentimes get the concept of the distribution, but what they always tend, that odd mistake that comes right in the middle of the problem, is where they distribute the number as opposed to distributing the number and the sign. So therefore then, just as a reiteration here, we simply distribute minus 3 into the bracket. Remember, a sign that appears before a number or a term belongs to the number. So if you're going to be distributing the number, ensure to distribute the sign as well. So then we are distributing minus 3 with 5. That gives us minus 15. And of course, now you notice here that a negative multiplied by a negative gives us a positive here. So too often that I find that students, when we start to do more advanced questions, you find here that they always seem to bring down that sign as is, and then that causes a domino effect in their results, hence giving them the incorrect answer. So then not all the time that the sign that is here comes down. Sometimes, well, most times that the sign outside affects the sign inside. So therefore we end up with negative 3 multiplied by negative 2 gives us positive 6y. Okay, very simple. So that is the essence behind the distributive law. Now, do we have decimals that we could distribute? Yes, in hindsight, we can have anything outside of the bracket. Now, as it relates for algebra, I think we have pretty much put a limit on what is it that we really distribute on a regular basis. So here we have positive whole numbers, negative whole numbers. Let's extend this concept then to a variable. What if it is that a variable, say x, then is outside of the parenthesis, and we end up with, say here, 4 minus 3y. Okay, so how do we expand this then? Because we can't evaluate it because we don't know what the value of y is, and we don't know what the value of x is, so we cannot calculate or evaluate. What we can do is simplify, expand and simplify. So here we say x multiplied by 4 is x multiplied by minus 3y. So now x multiplied by 4 is in fact 4x, and x multiplied by minus 3y, well, x times y is xy. There is nothing to multiply the number with, so the number comes back as minus 3. So x multiplied by minus 3y becomes minus 3xy conventionally, but at times you're going to find students writing down 3yx. We prefer to always write our results in alphabetical order. All right, and then say then, what if we have, say here, a number and a variable? So we did positive whole, we did negative whole, we did variable. Let's do a combination. Let's say then we have let's say then that we have 4x open bracket 2 minus 5y. Let's do something like that then, right? And what I'm doing here is that in this one introduction video, I am covering a wide variety of possible expressions that you can get to expand and simplify. We're not just touching just the basics, but we're touching the basics of the advance. So here we have, say here, 4x multiplied by 2, and 4x multiplied by negative 5y. Now, I kind of like to make it simple for my students by telling them to multiply number with number and variable with variable. So here 4 multiplies 2 gives us 8, and since there is nothing here beside the 2 to multiply the x with, the x simply comes back, right? Minus then 4 multiplied by minus 5 is minus 20, and of course x multiplied by y gives us xy. So far all these questions seems to be quite simple. Then the question begs, why, when it is that we put them all together, then students may get it incorrect? Sometimes again, there might be a little gap in the learning. There might be a concept that you thought you understood that you really may have just overlooked. So again, let's do 2 more examples then, and of course expand another aspect of this then. So let's say then we end up with a situation like, say here, 4 minus 5 open bracket 3x minus y. Okay, let's say we have an example like this then, and you're asked to expand this expression. Now, what I find fundamental, and I've been teaching maths for more than 10 years, and I've been teaching Csec, all levels of maths, college math, and I find that even at the higher level, this is a fundamental algebraic mistake where students completely forget that the PEMDAS rule applies not just numerically, but it applies algebraically. So here in this case, where I find that a lot of students make the mistake by starting off by subtracting the 5 from the 4. Let's not make this 4. Let's make this something more obvious. Let's say 9. Let's say 9 take away 5 open bracket 3x minus y. Now, I'm almost certain, and if you can be honest with yourself, if you got this for the first time without any form of knowledge, you are probably going to be tempted to saying 5 take away 9 is 4. Then you probably would put back your 3x minus y. Then you'd probably go ahead and distribute. And whilst that seems so correct, leave it in the comment section if you're that student. Give me a thumbs up if you're that student that probably would have made that mistake. This is going to be absolutely incorrect. Now, for 2 reasons. For 2 reasons it's going to be incorrect. 1, we are not allowed to subtract before we distribute, or simply put, to multiply. So subtracting that 5 from that 9 is a crucial mistake that a lot of students, believe it or not, students struggle with algebra simply because this fundamental concept was not explained. Secondly, we have a multiplication then. And so naturally, even if the brackets weren't there, then we would still have to multiply the minus 5 by the 3x before we even think about subtracting. So we have broken 2 rules there. We have added before we multiplied, and we have subtracted before we multiplied, and we have also subtracted before we really distribute. So how do you actually approach this question? What's the correct way? The correct way is simply to rewrite the 9, take away, and we're going to be distributing the minus 5 inside the bracket. Now, one of the things that I also find, and let me just quickly erase this step that we're taking here. What I also find is that some students tend to overread the instruction where the distributive law. This is why in the instruction that I had given you up top here, I placed in red here, immediately preceding the bracket. And why is that so powerful? Because too many times over I've seen where students distribute the 9 here, then they try to distribute the 5 like this, and whilst it almost feels like it's correct, you're gonna find here that you're going to get this question incorrect. So rule, do not distribute over a term that immediately precedes the bracket. All right, always distribute the term that immediately appears before the parenthesis. So the correct way here to do this is to rewrite your 9 and distribute the minus 5. So what we have here is negative 5 multiplied by 3x gives us negative 15x. And of course, remember, the sign is being distributed. Negative multiplied by negative gives us positive here, and this is in fact going to be 5y. Now in this example here, we can't really go any further. That's as much as we can get from that expression because all the terms are unlike. Now, had it been a case where maybe this was a number, then let's put say 10. All right, let's put say 10. Then what we're gonna have here is in fact, rather than as opposed to having 5y, would have ended up having -5 multiplied by -10 is in fact positive 50. Now with this expression we can actually go further because then we have a numerical value here and a numerical value here, so we could actually add those two. So we could say 9 plus 50 take away 5x. Therefore then what we have is 59 minus 5x. All right, so it really depends on the expression. After you've distributed, your objective is seeing here where you're looking for any like terms. All right, so hope that cleared up a lot for you there. I do have one more example that I need to do, so let me just create some space here. Please take a screenshot of what I've just did. All right, and we're going to be moving on to just one last example. I want to give you as much, I want to expose you to as much of the basic of the advanced distribution questions that you're going to be facing, not only at the Csec level but also at the advanced level. Now it could be a case where we have a term that is in fact outside the bracket where it has a power. Let's say it could be something like x to the power of, let's keep it simple, x squared, and we need to distribute it with something on the inside. Let's say then we have 3. Let's make it challenging. Let's say x squared multiplied by 3x y minus 2. Let's say let's do another x. Let's do x cube y squared. Let's do something. This is advanced. All right, this is advanced in my expectation here. And what I'm trying to do is that we're trying to merge all that we've learned so far in this one question. Now this particular question here, this simplification here, is somewhat connected to a previous video that I had done. That video there is called multiplication and division of algebraic terms, where we looked at what is it that we do, what are we in control of when it comes to distributing variables with powers. This is the only time that we interfere with the powers, and the rules simply state here that once you're multiplying, you're going to be adding the powers. You can definitely look out for a tutorial on that. It's called the laws of indices application. That video is coming out soon and very soon, so definitely be subscribed and hit the like button and await the release of that video. So definitely when we are multiplying, what do we do with the powers is to add the powers regardless, and when we are multiplying, when we're dividing, pardon me, we subtract the powers. Now here is the challenge with this question. The challenge here with this particular question is the fact that even if a student recognizes that this needs to be distributed, it always just causes a little bit of worry, apprehension, like, am I going to get it right? Am I going to get it wrong? Here, what you have to understand is that the letters are going to be multiplying the letters. Let's put a number here. Let's put a number here. Let's put, say here, 4. Okay, 4x squared. Let's make it more challenging. Let's put 5 here. Okay, all right, so this is looking more like an exam structured type question, and we're making it challenging here. So let's do number with number here. So let's do 4 multiplied by 3. That gives us, say here, 12, and the x is going to multiply the xy. Letters, variables multiply variables. So notice here that this x squared here is going to multiply the xy. Please note that this x here has a power of 1. Remember, we said this, that once you have a variable without an indicated power, the power understood is 1. So technically this is x squared multiplied by x1. So let's go to the side here, x squared. And you're not going to be doing this when you're in your exam. Okay, when you're in your classwork, you don't have to write it down to the side. This is just me breaking the problem down for you here, so you can see exactly what is it that we're talking about. So what you're really doing is that you're multiplying x squared by x1, which is x squared to the 2 plus 1, because when we're multiplying, we add the powers. So therefore then x squared multiplied by xy becomes x to the x to the 2 plus 1 is x cubed. So this becomes x squared times x1 is x cubed y. Okay, now if there was a sign between here, then we'd have to distribute again the 4x squared with the y, but the y and the x and the 3 are called monomial expressions, composite monomial expressions. Okay, take away our minus sign here. 4 then distributes to the minus 5, gives us minus 20. All right, and then now we have x squared here multiplying x cubed, x squared multiplying x cubed, that gives us x to the 2 plus 3, that's x to the 5, so that's x to the 5 y squared. All right, and that there becomes our simplified expression. So for the students who may have seen this in your college classes or in your algebra classes and find it quite challenging, find it a bit confusing as to why the teacher would have written down something like that, then really guys, it is coming from the fundamental concept of algebra. So do check that video out. It really does break down a lot for you here. Now there is a lot more to this because we can distribute fractions, we can distribute terms with fractional powers, but we're not trying to make it too complicated. All we're trying to do here is to simply expand our knowledge. Now that I've been through all the possible examples that you can literally go through here, let's do some practice questions. We've done a lot of advanced stuff already, but what I have here on the screen are just some quick examples that I'm going to be running through. So I'm going to be quickly running through like just a random 4. There's about 8, so I'm going to be running through some random 4. All right, just picking 4, and then of course you guys can do the rest and leave your answers in the comment section, or as well as leaving your name. All right, and of course we're going to be extending then to some more traditional exam structured type questions. Then we're going to be pumping it up a little bit here with some more advanced examples here. All right, so we're going to be having some fun for the next 20 or so minutes. We're trying to keep this video under an hour. So let's start off with easy to medium problems. Here I'm going to be picking number 1 as a start here. So we're distributing the 7 here. So 7 times 1 is equal to 7, and 7 multiplied by minus 8, that gives us minus 56n. All right, nothing we can do there, very simple. Here we have an example number 4. We're going to be distributing this minus sign here. Now very important you guys understand that when we are distributing a sign without an obvious coefficient, then the actual coefficient is understood to be a 1. So as opposed to a lot of instructors saying that you should distribute the sign, what you're actually doing is that you're distributing minus 1. So minus 1 multiplied by 3x gives us minus 3x, and of course say here minus 1 multiplied by minus 9 gives us positive 9. Okay, positive 9. Okay, beautiful. All right, and so let us do say here this example number 8 here. So we're going to be distributing the minus 4 here. So minus 4 multiplied by 4 gives us minus 16, and minus 4 multiplied by 3p gives us minus 12p. All right, and that there gives us our expansion. Remember that most times in distributive law you don't find where you are able to add the terms. All right, beautiful, or subtract the terms, pardon me. Let's move on to some easy to medium questions again. Now I'm going to be starting off with this particular question here. All right, and so what you're looking at here is us distributing, say here, the minus, say here. Okay, we're going to be distributing the minus 6. So what we have here is minus 6 times x is minus 6x, and minus 6 multiplied by 2 is minus 12. Take away minus 2. And so as I said earlier, that most of the times you won't find that you can add or subtract the terms after the distribution, but when you have a number outside, it may simply calibrate with a number that was distributed from the inside. So here we have minus 12 minus 2. Those two are alike. So we can say minus 6, say here, minus 12 minus 2 is minus 14. Okay, minus 14. I do find quite a lot of my fundamental students oftentimes forgetting, or not even forgetting, oversighting the fact that this is not a 12, but it's a minus 12. You find that a lot of students will say 12 take away 2 is 10 and rewrite the negative. As I've advised you before, also in my live classes, that the sign that appears before a number belongs to the number. All right, so there we have minus 6x minus 14. And so I also find that this example could also be a really tricky one as well. So here, the temptation, and leave it in the comments below if you're the type of student that if you were to get this problem, you are probably going to be saying 4n times 7 and 4n, say here, by 6n. If you are that particular student that would have done that, then of course you know that you've just made the incorrect step. Remember that it is the number that immediately precedes the bracket. And you might ask, isn't the 4n immediately in front of the bracket? Well, as we said earlier in a previous example, if a sign appears before a bracket without an indicated number, then the number understood here is in fact a 1. So you cannot skip over and distribute the 4n over the 1. Tricky example here, guys. Very tricky example that you guys oftentimes will meet the error with. Okay, so now we're going to be rewriting the 4n as opposed to distributing the 4n. So 4n take away negative 1 times 7 is negative 7, and negative 1 multiplied by negative 6 is positive 6n. All right, and now in this question here, we end up having terms that are alike. So we have 4n, then say here plus 6n, take away 7. And then easily then we end up with an answer of 10n, take away 7. Such a tricky little question, probably valued about 1 or 2 marks in an exam. So when you get these type of questions, you can easily make a mistake by distributing the 4n as opposed to distributing the minus 1. All right, lovely example there. Let's move on to this next question here that we looked at earlier, and you can see that all that we have done in the fundamental part of this video is literally coming back, because as you can see, these are technically worksheets taken from a Google website. So here we end up with a temptation here where students may have enough knowledge to know that negative 3 minus 7 without the brackets would have been minus 10. As well as you may still have the student who fundamentally think that 3, this is a 3 as opposed to minus 3. They may say 3 take away 7 is 4. My students give me a wide variety of answers sometimes. So they'll say 3 take away 7 is 4, and negative multiplied by negative is positive. And there's just so much going on here. The moment that you may have missed an algebra class or you missed a fundamental lesson, so many different things can go wrong if you're not very much strong in this area. So of course the aim of this video is to clear up any possible ambiguity that you may have when it comes to simplification of algebraic expressions. So here, as said before earlier in the video, minus 3 minus 7 here is in fact, as opposed to being minus 10, we're going to rewrite the minus 3 and we're going to be distributing the minus 7 inside the bracket. So minus 3 minus 7 multiplied by minus 3 is positive 21. Minus times minus is positive again, and 7 times 6v is in fact 42v. Okay, so see how easily you could have made that mistake? Leave your thoughts in the comment section, guys. Let me know if you would have actually made one or both of the mistakes that I mentioned earlier. Now we end up here with minus 3 plus 21. These two terms are in fact alike. So minus 3 plus 21, guys, it is not minus 24. Remember, this is minus 3, which means that you owe, and 21 means that you have. Paying what you owe literally is going to have us having 18 left. So that's 18 plus 42v. All right, and we're not going to distribute or factorize our answer. That's a video that's coming up next. So we're going to be doing what is known as the reverse distribution law. So ensure that you share this video out to all your friends. If you're watching this, help another student to become strong. If this video is benefiting you, most likely it will be able to benefit another student who may be struggling. All right, so we're not doing the reverse distribution law because of course this expression can be written in a more simplified manner, but we're not going to be going to that route there. All right, so go ahead and give, say here, question 12 a try and leave your answer in the comment section. Now we're going to the medium questions then, and so with this question now we're looking more at exam structure type question. This is typically what you may go on your exams and see, valued 2, maybe maximum of 3 points. So let's get into it here, guys. So what we're looking at then is, in fact, let's say look at number 13, let's look at, say here, number 16, and let's look at, say here, number 15. All right, and then you guys can of course leave to question 14, 17 and 18 and leave your thoughts in the comments below. So what do we have next is, in fact, to distribute the 7. So here with here and here with here, keeping it simple at first. 7 multiplied by 5 gives us 35 along with the n, and 7 multiplied by minus 8 is minus 56. Yes, then we move on. Positive 6 multiplied by 4 is positive 24, and positive 6 multiplied by 6n is positive 36n. So therefore then we can group like terms. Now traditionally we like to write the variables before the numerical values, but it doesn't matter if you write the numerical values before the variables. At the end of the day, the answer will have 2 terms that are not compatible for addition or subtraction. So then I'm going to be starting off traditionally with grouping the variables. 35n plus, say here, 36n minus 56 plus 24. And if we add 35 and 36, then you're going to find here that we end up with the answer being 71. So that's 71n, and minus 56 plus 24. So let me see here, that is 32. Is it? I think it's 32. So yes, it's negative 32. So that's negative 32n. Let's double check on that. Right. Yes, it is negative 32. So you owe 56, you have 24. Pay the 24 that you have, you owe 32. And that is your simplified answer. Okay. Let's then look at question, say here, 15. All right. Now, what we're looking at then is, in fact, distributing the minus 5 here and here, distributing the minus 8 here and here. All right. And there's going to be a lot of sign clashing here. So minus 5 times 1, that's minus 5, and minus times a plus gives you a minus, so be careful not to bring down the sign. The minus outside affects the sign inside, so that's minus. 5 times 2 is 10k. Okay, next we're going to be distributing the minus 8, so minus 8 times minus 4 is positive 32, and negative multiplied by a positive gives us a negative here. 8 times 5 is 40k. So by grouping like terms, then we end up with minus 5 plus 32. I normally like to group by the term that I see first. So if I see the number, I tend to want to group the numbers first. So minus 5 plus 32 minus 10k minus 40k. Okay, and then easily then we end up with an answer here of minus 5 plus 32. That works out to be positive 27. Remember that this is not positive 5, so for my students who's thinking that this is minus 37, that's where you're going to be going wrong. So minus 5 means you owe, 32 means you have. Pay what you owe and you're still going to have, say here, 27. And then of course you owe 10k. Let's think about money. You owe 10,000 and you owe another 40,000, so now you end up owing 50,000. So now the answer becomes 27 minus 50k. That is our simplified expression. All right, and then now let's look at another example. Right, final example from this section here. We're looking at, say here, distributing the 5 here and here, and the 5 here and here. Okay, so then we end up with 5 multiplied by negative 3p becomes negative 15p, plus 5 times 7 is 35, plus 5 times p is 5p, and 5 times minus 1 is minus 5. Okay, so now we group like terms, minus 15p plus 5p plus 35 minus 5. See, we're moving a little bit faster now because we're more confident in what we're doing. So then our final answer here works out to be I owe 15 and I have 5, pay the 5 that I have, and I'll still owe 10p. And so therefore then 35 take away 5 is in fact positive 30, and there is our final answer. So do you now understand that with strong fundamentals in simplification of algebraic expressions will increase the speed or the rate at which you work your questions? Now, to be very efficient and to complete your exams in time, your fundamentals have to be very, very strong. Strong fundamentals means strong students. Strong students means more confident student. More confident student means more confident and consistent results in your math exams, monthly, tri-weekly, or yearly. All right, beautiful. So these questions at the bottom are more or less the same. They are the same. There's no trick in this. Distribute the 11, distribute the minus 2, distribute the minus 9, distribute the minus 2. So there's no trick here. I'm going to be allowing you guys to leave your answers in the comment section down below if you've gotten it right, and I will definitely be sure to respond to you. Just ensure that you put the number and the answer in the comment section. Looking forward to hearing from you guys. Okay, so we're almost to the end of this particular lesson here. Now there are of course some more examples that I have here. I'm going to be just picking maybe one that looks maybe a little tricky. I'm going to be doing, say here, 2 for you. I'm going to be doing question 7, and I'm going to be doing question, say here, 6. Question 6 and 7. All right, by me doing question 7, you should be able to have a very good idea of doing question 9, and by me doing question 6 will avoid one little trick that may catch you in the future. All right, so let's do question number 6 here and then bring this video to the end. So here what we have now is 6y. Let's zoom up here. So we have 6y, take away, open bracket, y plus 5y plus 3y. Wow, that's a lot. So looks a little tricky. All right, here's what we're going to be doing. We have every term being a y. So there's no unlike terms here. There's not a number and a variable. They're all y's. But there's a little thing that we must do before we can really get to our answer. This term is in a bracket and there's a minus sign outside of it. So we have to distribute the minus sign. And again, do not be caught by distributing over a number. Remember that this number that is here that is understood is a 1. So be careful not to distribute the 6y all over. That's how, over the minus 1. So the 6y comes down here. And minus times y, minus y, watch this. Minus changes the plus to a minus and 5y. So as opposed to us adding, well, we end up subtracting. So all the terms are alike. Very simple question that appears to be a little bit tricky. 6y minus 5y is 5y. 5y minus 5y is 0. 0 plus 3y is in fact 3y. Perfect. Perfect answer there. All right. Question 7. Again, the temptation to try to subtract the 8 from the 7. Well, if you do that, mathematically the answer is minus 1, but algebraically you're going to be incorrect, because again, we do not subtract before we add, before we multiply or distribute. So here the 7 will come back down, minus 8 here. Minus 8 times minus 2 is minus positive, 16. Almost made a mistake there. And the negative multiplies the negative, gives us a positive. 8 multiplied by 5 is 40x. And so the only thing that we can literally do here is to add the 7 and the 16, which gives us, say here, 23 plus 40x. All right? And that gives us our simplified answer. So there's a couple of questions there for you guys. You can screenshot those and work through them. All right, so what's coming up next, as you can see here pulling up on screen, is in fact the binomial expansion. We're going to be expanding what we've learned so far into another type of algebraic expression simplification, the binomial expansion. So do hit the subscribe button below, turn on the post notification bell. I do post videos every single day from 5 p.m. until 9 p.m. the live classes that I keep during the week. Those classes can be quite entertaining, and of course it gives you lots more advantage to getting on and improving your math. So as I said, binomial expansion using the FOIL method, and we're going to be looking through those. So look out for that video, guys. So until then, take care, and I'll see you in another tutorial. Keep on practicing, keep on improving, and being objective with this beautiful language of the universe. Until then, take care. Bye-bye.
Csec Math Exam Preparation. Quiz number 2. This is where the grade 1 all starts.